Hello, I'm Mr. Tapia, and this is part 4 of balancing chemical equations. And so we're going to jump right in. So, like any equation, we always start with finding the inventory, or inventorying both sides of the equation. The whole reason we balance chemical equations is that what we have in the beginning of the reaction, basically on this side, is exactly what we have on the right side of the chemical equation. And so in order to do that, the first thing that we need to do is take inventory. Alright, so let's get started. Alright, so we need to first draw a little line in the middle of the page and kind of splits our products from our reactants. So on this side, as you can see, we have aluminum and bromine, and so we're going to go ahead and pair those together. Here we have potassium, which is the K, and we have a SO4, which is a molecule. And SO4, because it's represented over here, can just kind of be kept together. It will make all the math easier if we keep them together. And so we have a potassium and we have a sulfate. And on this side, we're going to go ahead and do the same thing. We have potassium and bromine again. And over here we have aluminum and sulfate. So this part I've titled 4A, and that's because I'm going to go just a little bit slower and kind of explain it as I go. Remember, the whole way through is balance. So if you balance one, you will balance the rest of them. You're probably wondering what I mean by that. So the general rule of thumb that I like to follow is to find the biggest molecule and to work it first. Before that, though, we need to figure out the multiples of each set of molecules. And so as you can see, aluminum here, it doesn't have any numbers right there, and so it moves in sets of 1. So 1, 2, 3, 4, 5, 6, 7. As you can see, bromine here has the 3, and so that means it moves in sets of 3. So we have 3, 6, 9, 12, 15, 18, and 21. As you can see, we move over to potassium. Potassium moves in sets of 2, so we have 2, 4, 6, 8, 10, 12. And as you can see, the sulfate, we're just going to keep this thing together. So this right here is SO4. There's no parentheses and a 1. And so this is just 1 sulfate. So it moves in sets of 1. Now, on the other side, or the reactant side, as you can see, we have potassium. And potassium has no numbers next to it, and so it just moves in sets of 1. As you can see, we have bromine here. Bromine also moves the same way because there are no numbers next to it. And finally, we have the last little molecule here. We have aluminum. There it moves in sets of 2. As you can see, there's a 2 there. So we have 2, 4, 6, 8, 10, and we'll go ahead and say 12. And sulfate, as you can see, sulfate has a 3 next to it, and so it moves in sets of 3. So we have 3, 6, 9, 12, 15, and 18. Okay, so the biggest question I get on these kinds of problems is where to start. So the general rule of thumb is to always go for the biggest molecule. And as you can see over here, this one looks the most complicated. I mean, it's aluminum sulfate, okay, and it's got a bunch of stuff over here, and none of the other ones look very complicated. So I'm going to go ahead and switch colors, and let's see how we do this. Okay, so alright, so the first thing that we're going to do is select the first molecule. We didn't pick any other one but just the first one, so we're going to pick the first one. So we circle the first one, and I'll probably need to change colors here. I'll do yellow. So if we look at aluminum, we have 2 atoms of aluminum in this molecule. So this molecule is comprised of 2. And so we need to figure out if there is a place over here that has a 2. And so basically what I'm saying is that does this 2 line up with another 2 of aluminum over here? Well, aluminum is right here, and there is a 2. And so we can go ahead and circle that one. So basically I went from here all the way over to here. Okay. Now that I'm over here at aluminum, does the bromine line up with it? Well, this bromine here is 6, and I know it's difficult to see because I just drew a line through it. So let me make that line a little bit easier to see. Okay. Is there a 6 represented on this side for bromine? And so if you'll look, you go down here, and okay, so I didn't completely finish, but as you can see, I go to 6 and 6, and there would be a spot right there. And so from here, I just balanced bromine. Now, from here, is there a potassium that's 6? Well, as you can see, there's one here, and so I can circle that one, and from there, I can go back up to this one. Lastly, as you can see, we have a sulfate here, and there's 3 of them. Does that line up with the original 3? And of course, the answer is yes, it does. So, everything is completely balanced. We have 2 aluminums on this side, 2 aluminums on this side. We have 6 bromines on this side, 6 bromines on this side. Potassium, we have 6 as well. And as you can see, we follow it down. We have 6 here. And for the sulfate, we have 3 here and 3 here. So now the question is just how do we get the numbers? Do we plug in here? Well, we really just count downward. So if we count down, we have 1, 2. So we've gone down 2 spaces, and so that would be a 2. This one we have 1, 2, 3, and so 1, 2, 3. We went down 3 spaces, and so that would be a 3. We went down 1, 2, 3, 4, 5, 6 on this one, and so that would be a 6. And we went down 1 over here. So I guess the real question to ask here is, did it all balance? And so if you look, we have 2 aluminum, so 2 times the aluminum. 1 times the 2 is a 2. We have bromines, we have 3 of them, so we have 2 times the 3, which is 6. And over here we have 6 times the 1, which is also 6. Here we have 3 times 2 potassiums, which is the K. And over here we have 6 times the 1 K, which makes 6 as well. Lastly, we have the sulfate ion, or the sulfate molecule. So 3 sulfate molecules right here. And if you look, we have 1 times the 3, which equals 3, and then sulfate molecules there. So as you can see, we have a fully balanced chemical equation, and I pretty much just took you through exactly where I started here, followed it over to here, and down, back up, and then back over to make sure it all balanced. And it does balance, and so those are the numbers we pick. I hope you enjoyed this video. Thank you for watching.